He said, my name is Kurt Rasmussen. I'm with Bentley Systems. I've been with Bentley about 5 years, and my career started working with photogrammetry and then moved into dealing with LiDAR and point clouds. I now have the pleasure of working with both using our products ContextCapture and ContextCapture Editor. Now today I'll be focusing on ContextCapture, how we acquire this information using some drones. I'll show you some samples. What I want to show you today is how easy it is. Basically, with very little experience, I know we do emphasize that photo acquisition is very important. I can also tell you if you're not exactly on, depending on the sensor that you're using, if you have a good camera, it gives you a little more leeway. Also, the drone that I'm using has some safety features for GPS and stabilization, so my photos come out very crisp and clean. Gives me a very accurate model. So today, as I mentioned, you'll see ContextCapture, ContextCapture Editor, and Descartes. So if you're a user that's already has Descartes or access to Descartes, not a problem. Everything that I'm showing you today you could do in Descartes. As well as if you're just a ContextCapture user and you acquire the ContextCapture Editor, you can also do what I'll be showing you today. Today I'm going to extract ground. I'll do it live in front of you. It takes a couple minutes. It's not a big site. But it will give you the concept of what we do, how we do it, and I'll get into some details. We'll also cover scalable terrain models, which are very dynamic surface models that we use. I'll cut some cross sections, create some break lines, and then we can model by section. So extracting ground, basically the first step is to create random points automatically. It's very quick to do. We can check it. There's some more technical levels that I get to depending on a complex site. Today is a rather simple site, but you could always work with me and we can go through more complex sites if need be. I'm going to hop into a new file that I have here. You're going to notice that I have some of my tools docked. I was never a big fan of docking, but pretty much when you have these big dialog boxes and I'm trying to show it on one screen here, it does save me a lot of time. So what you're going to notice along the bottom, I have my point cloud toolbar dialog box, which is docked down here, and it flies away just when I hover over it. I have my reference files, my scalable terrain model, and my reality mesh. If at any time you need to acquire these, most of the time you can go through the attach toolbar. And here we have our point clouds, reality mesh, scalable terrain models, and rasters. I do want to also point out this little dialog here, or this little button here in the bottom right corner. That will open out this dialog box for you. So don't ignore this little button. It is important to pull out. For example, I don't have my rasters open, so I can pull this out. And if I want to dock that very quickly, I can go down to this bottom area. It docks for me, and I can take out the push pin so that it hides away for me. All that being said, let's get started with the reality mesh model. As I come over here, I'm going to hit the attach reality mesh, and I already browsed to it. I do want to apply the geographic coordinate system. I used a drone that had GPS in it. It's not the most accurate, but it definitely puts me in the right ballpark. So I'm going to say OK there. We see here we have a site. Nothing very large, but this only took me a couple minutes to acquire. If we go back to the original file, what happened was the first day I started out and I walked around it with my cell phone. Now using a cell phone, I can get a lot of information. You'll see down here, even in the pavement, if I turn off the textures, we can see there that I can see the saw cut that was put through that pavement there. Also as well, if we look over here to this crack in the pavement, if I turn off the texture, it's very obvious to where the crack is. So just using an iPhone, I'm able to get some good detail on this, but what you're going to see is my roof is missing. I also couldn't cover enough ground. The time that it took me to walk around and do all this, I could actually fly a drone and do it a lot faster. Then I did come back and go with the drone, and if we take a 3D view here, we could see how I flew this. Now I didn't use any flight navigation software. Although it's out there, there's a lot of third parties. Drone Harmony is a good one that you could use. You'll see here I started out very well. I went forward in one path, and as I started coming back this way, I kind of collided into my other path. Also, you're going to see that the building structure that I'm looking at is over here. I only have my obliques over here. Really, I needed to do a couple more nadir images. I was kind of fighting with sunset. It was in the evening time, so, and also battery life. Uh, I have about 20 minutes battery life, so I just flew this real quick. It was a real quick example that I was trying to do. Just try to see the results that I got. So as you see, my flight pattern, we're supposed to have 60% over, at least 60% overlap. You definitely want probably 70 to 90% overlap. Doing some nadir images. These are the nadir images which go straight down. We see that it's a straight down view if we look at it over here. Completely straight down. Those are called nadir. Then we have our oblique images where we can see here the obliques. Now this tree was kind of in my way. I had to go around the back of it, but you'll see the amount of detail that I still get from there. If we look at the final model that's produced, we can see it here. We also see the camera positions that I had. Now this is a site that they're actually going to start some construction on the left side of it. They've ripped down some things. But I'm going to show you when we actually zoom into, this was 180 feet in the air, the drone was used. If I turn off this texture here, you can see the detail that we have here. We can also see, like down here where there's a crack in the pavement, we're able to see this crack down there. So even just using the drone, you're able to get a lot of information, a lot of detail. As I said, this was 180 feet, so you could go lower to get a little more detail. Definitely use a lot more nadir images than I used for better overlap. But my purpose is to show you that with inexperience, you can come out here and just fly. Make sure you take enough pictures, especially the obliques when you go around the side. That's where you'll get a lot of the detail. But you can see here, even the equipment around the side, we have full detail of that. So you definitely could start out with a site plan this way. As I said, this took 20 minutes and probably about an hour to process, not very long. I do want to point out that we have release 7 that was just released. It's about 30% faster than the previous one, so it's a good idea to hop on and get that. Hop online and download the latest version of ContextCapture. Now what I'd like to do is now take this and move into either ContextCapture Editor or Descartes, depending on which product you're using. In this case, I'm using ContextCapture Editor. As I said, you're going to find that nearly everything is the same. Now once we bring this mesh in, there's several things that I can do with it. Number one, it's tangible. I can touch this, I can start throwing propose next to it and do things like that. But when it comes to surveying, and if you have a surveyor go out there, one of the first things they're going to do are pull out bare ground, give you ground shots, ground extraction. So if we come up here to our reality modeling toolbar, we have the extract button here, and this button right here, as I hover over it, it says extract terrain from reality mesh or point cloud. So what I'm showing you here, if you have somebody going out and giving you LiDAR, you'll be able to create a surface from that LiDAR too. Many times if you're getting airborne LiDAR, depending on the company giving it to you, it could be classified already. If it's not, then we have the ability to do it right here. Also, some of those things are algorithms that were ran, and they're not the best programs. You know, they don't do it fully accurate. For example, some street signs, utility poles could come up as vegetation because the software thinks it's a tree. In our case, our main focus is using the bare ground. So I'm going to show you here. I'm going to pick this tool, and what's important, we have the seed mode. I'm going to set it to automatic. This is going to automatically go out and it's going to calculate. Now what's happening is we have largest infrastructure size. If we hover over this ruler, you're going to see it says smallest side of largest man-made object. That's important. When I pick that, I'm going to come around. This is the largest man-made object I have, but this is the smallest side. So I'm going to come around here for my length. We see it's about 16 meters. The purpose of that is it's not going to make any tile smaller than this. This process is going to create tiles and compare tiles to the sides of that one tile. So if this number was, say, 5 meters, and we had small 5-meter tiles coming on this rooftop, and it looks to the right and looks to the left, it would say, this must be bare ground, and it would think that this is a giant mound of dirt. Now, when you deal with photogrammetry, you can have this with large tree clusters that they appear as ground because photos do not get through. If you are dealing with LiDAR, light distance and ranging point cloud, you will get many shots that have protruded through the tree canopy. So you'll get some bare shot ground or bare ground shots on that. And this process would be great through vegetation if you're using LiDAR. For photogrammetry, uh, you're going to find that open sites work great. We can extract bare ground. We have some trees, cars, and a building here. I'm going to have my seed points go to level default. Now, if I get really into editing this, and that's deeper than I'm going to show you today, I would go through, have my points automatically created on a level called seed. I will then look at those seed points and see if there's any on the rooftop or maybe up in a branch that could be wrong. I'd erase that, clean it up, make sure that there's nothing, no seed points that are created wrong. And then I would come back a second time, set this to points, my level would be seed, and then it would run that through and use those as its base. Since this is a simple site, I'm going to go through and actually keep my terrain at level 50 or at 5, halfway. This is adjustable and it's based on your site. Not every site's exactly the same, so we can't give you a definitive number to put in there. I definitely start in the middle, see how it runs, but typically most sites at a terrain of 5 work very well. So I'm going to output seed points for you to see. And you know what? I will make a level for seed for you so that we can make them larger. This way they stand out because I realize these seed points are going to be little black dots and you probably won't notice them. So for presentation purpose today, I'm going to do this, tell these to go to level seed. I want to create a terrain out of this, a scalable terrain model, and let's create some classified points also. So the lower left corner tells me to identify reality mesh or point cloud. So I'm just going to pick on this point cloud and accept it. Now it wants to create this file. I'm just going to keep it in the default location. It's a geopack tin file. We could also read in OpenRoads. I'm also going to create a scalable terrain model. I'm going to save that one. And a POD file, which is Bentley's proprietary format for point clouds. We see the process is starting phase 0 of 0. Oh, it'll be 0 of 3 soon. There we go. It's already on phase 2 of 3. Now during this process, it's creating seed points. It's also creating a scalable terrain model and a point cloud. Now here's a little trick. If somebody gives you a mesh and you want to create a point cloud from it, you can use either Descartes or ContextCapture Editor to run this process, and you'll get a point cloud completely from this mesh. Now of course we're just focused on the bare ground, but everything like the buildings, the cars, and the trees will still become a point cloud, but they'll be unclassified. I want to run this live to show you that it's not a very large site, and we're able to run this live within, I think it takes about 2 minutes total. It's also doing a lot of calculations. It's running algorithms to look at these points that it's creating, and also, like I said, it's creating many other points. So we see here these yellow points that were created, probably a little easier to see now that I made them large. We also see there's the mesh that's created, which is my scalable terrain model. And let's clean this up a little bit. One thing that'll help, if we look at our point cloud, and I change this from none because all the points are black, I'm going to come in and change it to classification. By doing this now, immediately we can see all the points that created were pulled out for the building. All the red ones are the ground shots. All the yellow are unclassified. So we see things like in the back here, there's some picnic tables. If I turn off this reality mesh so that we're not seeing it, and also my scalable terrain model has some triangles on there. Now I can also bump up, if we go to home, I can bump up the weight of my point cloud. So there's a little easier to see. The software automatically, and like I said, this was live, I didn't record this. I just ran this, it grabbed all the ground shots, found some vegetation, some shrubs, things that were sticking up, and automatically classified that for me. So I'm going to turn off the point cloud. Now we also, I don't want to get into point cloud editing in this conversation, but just to let you know, there are features in here. You see the cylinder that I'm using. This is set to grab the highest point within an area. So I can come and draw my line right across this roof edge very quickly, even though I'm just picking down here at the center of the wall. We see there that that was drawn automatically. And if I turn on my reality mesh, we can see that I went right along that gutter line. Now that is an advantage to having it as a point cloud, because I can use this smart snap where it's snapping to the highest point within a point cloud. I find this very helpful for doing rooftop edges and also bottom of retaining walls. We could mark out the bottom of this, having it grab the lowest point. Another method you could use is use your cross-section tool to cut a horizontal cross-section of this way, where you're actually cutting a section through your site, and you'll get an outline of the area this way. I'm going to turn off this point cloud. Now if we want to, the next step after we create this, we'd want to look at break lines. There's areas where we're going to want to draw some break lines. So let me pull up another file here. Here's a case where we have this reality mesh. It has some curb islands. Hold on one second. I had to try to fix the headphones because I need two hands to do this. When I work in 3D, it's very important for me to rotate. And if I have to come up here and hit rotate and pick my screen and grab this cross and move it to what I want to rotate about and then spin it, that's time consuming for me. So I stick with the standard tools where I just snap to an object, I hold shift down, press my wheel, and then I spin. So if I want to spin around this bush, I snap to it, I hold shift, press my wheel, and I can spin around that bush. That's very helpful when you're drawing in 3D. So I do recommend you get comfortable with that. I'm going to show you pretty simply here. We can draw some curb lines. I could come along here and draw my curb, just using standard ways this way. As we see when I spin it around, this line is drawn completely at the bottom of the curb. Very helpful if you need to draw in some line work. Now these things in our scalable mesh, we can import them as break lines. So as we've seen in that previous file, I had a scalable mesh that created ground for me from bare earth, but it didn't have break lines at top and bottoms of curbs. This is where I would come in here and add top and bottom of curb. Now also the same way that we did the bottom, we can come in here and do the top. And I'm snapping directly to this mesh. Now this model here, they did use control points, so it is important that you take advantage of survey information. So many people in this industry and on this call are surveyors and engineers that have access to surveyors. If you're new to the drone world, you could start out using something like I use that has GPS in the drone to get within a couple feet and get you in the right ballpark. It's very good for a rough layout of your site. A lot of measurements are going to come out good. The coordinates are going to be within a couple feet of where they are in the real world. Relative to each other, they'll be very accurate. You'll find measuring objects and all that look very good. As you need more detail, that's when you get a surveyor involved, where they can go out and do field survey with targets. There's actually some new tools that I heard. There's some targets that connect to each other where you could lay them out, and they will run GPS automatically where the target is, to give you that control. So if you don't have surveyors, that's another option, inexpensive. It's about $600 a target. and I think they come in sets of 10. So those are things that you can put out if you're still doing sites and you don't have access to survey. You can supplement your drone information with targets like that. Now also within context capture, we have the ability to create targets for you. So if you go out to tools, there's create context capture QR codes. So this will create a QR code for you where you can give it the coordinates, embed them into the lat and longs, or embed your lat longs into it, or whatever spatial reference system you're using. You can embed that into the code. So if you lay out your QR codes here in your site, the GPS or the AT will automatically see those targets and calculate and position your model for you. Now, if anybody's familiar with using these tools that were part of Descartes for many years, we have cross-section tools, model by section. I'm going to show you where I flip into a top view, and let's find a curve that I want to work with here. Let's go along this one. So here's a case where we do cut a cross section. I want to do a vertical section, and my thickness, I'm going to make it 6 inches, and I have it stepping forward 2 feet. Now it asked me to pick the first point on the plane. I'm going to come across here and pick here. Automatically it opened up view 2, which I had opened in the background. And here we're able to see that curb, and we see that the ground actually behind it is caved in a little. So they need some backfill on these curbs. But once again, I can come in here, and if I'm drawing the bottom of my curb, just like a surveyor would put his rod here and say, there's my bottom of curb, and then we have these feet to bring us forward, and you see this section here as well has moved me forward. I then can come again and pick that bottom of curb, step forward, and pick the bottom of curb. Now, I set up my function keys so that I can, instead of coming up to the upper right and hitting these feet, I press my function key and I jump forward. So you see here, as fast as I can click on the bottom of the curb, press my function key, it goes forward 2 feet, pick on the bottom of the curb, and we see this is drawing for me all along. Now I could do the same thing, just like a surveyor would go and probably go up one end of the street and then come back the other. I'm going to change this. Let me change my color to a green color. And now I'm actually stepping backwards using the same method. And as you will see here, I am drawing now my top of curb. And in this case, I used function key to do the back step. So the benefit to using this method, if your contract's telling you or states that you need to do 20-foot cross sections, anything like that, you can use this forward back step to follow that increment. But also having this over here in an isometric view, I'm able to see where there's some drain structures here coming in, or at least cutouts in the drain. We can see here the back of curb, how this island is recessed, and now we see why, because this is actually a drainage area. These lines then, when you have your scalable terrain model, can be input. Let me see if I have one for this site. So we see there, this is our scalable terrain model. These, I have them on level default, but what I would recommend is you make a level in here and call it breaklines. And if you want to get really detailed, you could call it top of curb, bottom of curb. So I'm going to grab these lines here, and we're going to move them to breakline. something else to point out, you can make your mesh transparent, which makes it a lot easier when you're comparing things against your mesh. So in this case here, we can see like here this triangle line's going from down on this sidewalk all the way up to over here. So that's really, these triangles here are cutting out the face of that curb. Here we got a triangle getting the top of the curb but not the bottom and stuff like that. So what I'd like to show you is how we can supplement this. And we're going to modify it. Oh, my file's read only. Well, in the meantime, the easiest way, I'll just make a new one. And here we have the option to add terrain, we can add random points, and we can add breaklines. Now in this case I want to add breaklines from a DGN level. And there we have breaklines. But let me bring in, first I'm going to bring in these random points that I do have in this file. So now I have my random points in here. And then we bring our DGN breaklines. And just this easy, you would hit select breaklines. We then see that it says it's dirty, so you need to rebuild it here. And we see the triangles reform quickly. We see these, they're now purple lines, but you see it going along the base here of my triangles to hold the bottom and curve. The blue lines that you're seeing are the previous one that was read-only that I wasn't able to change. I think that does hit us right at the time